We're going to learn step 2 of becoming human graphing calculators. You will need to know and be proficient at doing step 1. You don't have to find this question. We'll come back to it later. I'll give you a function. I'm going to eventually ask you to graph it. Step 1, take the derivative. You don't have to find this question. You'll set it equal to 0 or see when it's undefined to find the critical point. You don't have to worry about undefined. There's no denominator. You are proficient at factoring and solving set equation. Great. Step 1, check. What is step 2? How are we going to know if these are going to be maxes or mins? Okay, well, before I just tell you what we're going to do, I got to tell you why we're doing it. All right? All right, cool. So, when we first talked about calculus being the math of change, we said slopes are the key. Because slopes give you rates of change of function. And when we first got slope values, I had you interpret them. Like if you have a slope value between A and B of 1/3, the slope of a secant, it's an average rate of change. We would say on average, my function, we'll call this f, on average, f goes up 1/3 of a y per x on the interval from A to B. And then we said, well, if a slope of a secant is a change over an interval, the slope of a tangent is going to be the change at a point. And we can now say, hey, at this specific location, at x equals b, my function is going up 3 y's per x. And we have this point here at c, and its slope is -2. You'd say at x equals c, my function is going down 2 y's per x. Right? We started with that, like how quickly it's moving, and then is it going up or down? Well, like, what if I didn't have the function? What if I couldn't see the function? How could I know, based on my slope values, if I was going up or down? Tell your neighbor. If I couldn't see the function, how would I know if it's going up or down by looking at those slopes? That's the question. The positive slope means we must be going up so that the slope is positive. The negative slope means we must be going down to have a slope that's negative. Okay? This is key. This is the important thing we must understand to understand what we're about to do to get that step 2 to figure out if we have maxes or min. We have to understand that when our tangent slopes are positive, this is me drawing a bunch of tangent slopes and labeling them as positive, f prime positive. Here, tangent slopes are positive. If my tangent slopes are positive, my function is going up from left to right. When my tangent slopes are negative, in this interval, my tangent slopes are negative. I'm going down from left to right. When my tangent slopes are 0, I flattened out. Constant. Okay? Now, we are not going to do f prime equals positive. We will be using plus and minus symbols. But another way to write something as positive is to say it's greater than 0. If f prime is greater than 0, f is going up. We'll say going up, we can draw an arrow from left to right. We're saying going up from left to right. We're back in America. We like to read things from left to right. Or we could say it's increasing. Another way to say a derivative is negative is to say it's less than 0. I'm going to write this, but my translation is not like f prime is less than 0. I'm saying f prime is negative, and then I write that. Negative values are less than 0. Well, if f prime is negative, f is going down. You do an arrow that's going downward from left to right. I don't like to go just like straight up. I like to make sure I have like direction from left to right, from left to right. I'd say it's decreasing. And if f prime equals 0, f has flattened out. Or you'd say it's constant. Yeah, we're just gonna say it's constant, it's flattened out. You could do this if you want. Yeah. All right. Now, we won't always live in f prime land. Okay. Sometimes, and eventually, we're going to look at like the physics and calculus connection, and we'll talk about like velocities of objects and stuff like that. And I might ask you like, when is the velocity increasing of this object? Well, no longer are you guys going to like create a table and like look at y values and hope to see them going up. You now are calculus students, and you will know that something will increase if its derivative is positive. So right now we stay in f prime land. Okay? But in the future, we're going to go, hey, when's your velocity increasing? You look at the derivative of velocity. Same rules will apply though. Nothing will be that crazy. Well, actually, later in this unit, we're going to look at when f prime is increasing. Well, f prime is increasing when its derivative is positive. What is f prime's derivative? Oh, it's interesting. Sometimes we might have to look at second derivatives to see when first derivatives are increasing. Okay? Something is decreasing if its derivative is negative. Something is constant if its derivative is 0. Question?
You have a negative x, and then you say like x to the fourth, that would make it positive, but then you take the derivative of that, you get to the third, and you negative. That's
Signs of derivatives sometimes will vary from signs of original function. Okay? But signs of derivative is important. So what we are going to do next, and this is important because this is going to help us figure out if we have maxes or mins, is we are going to say, hey, here's a function. Okay? I don't know what it is. But you'll do step 1, you'll take its derivative. You'll set it equal to 0. You'll solve. And let's say it's got one critical point at C. Let's pretend C is a number. Ready? Here comes step 2. I won't tell you how to do it yet, but this is what you are going to eventually produce. Step 2 is to throw down a number line. Completely new, never done it before in this class. You might have seen it last year. You will take your critical point, your number when your derivative is equal to 0. You're going to plop it down on your number line. If you have multiple of them, you'll plop both of them down. Okay? And what we are going to do is we are going to analyze signs, positive or negative, of f prime. And I'm going to tell you how to do this. Now you know that the derivative of c is 0. So you know your function has flattened out at this x equals c. But you will be able to find the signs of f prime. And let's say you found that the signs of f prime were positive to the left of c. And let's say you found, and I'll show you how to do it later, that the signs of f prime were negative after c. Would you be able to pick out which one of these graphs would be the graph of your function? Go ahead and tell your neighbors. Which graph would work? Which graph would would be the situation there. Yeah, so if, and this is what we're going to do as well, if f prime is positive, I'm going to throw another thing underneath here. Ready? Throw f underneath. If f prime is positive, f is going up from left to right. If f prime is negative, don't fall asleep on me now. F is going down from left to right. So by looking at signs, we know we're going up, flattening out, going down. I can then say, oh, my graph must look like this. And oh, I know x equals c, not only a critical point, but it's a what? Max. Max. Right? So if I could produce this, boom, I can not only say, hey, I don't only have a critical point at C, I have a max at C. Now, what would happen, though, if I did the analysis, and we're about to figure out how to do this, and I got positives for f prime sine to the left of C, and I got positives to the right of C. What situation would I have now? Which one? Ooh, would it be a minimum? It's actually one of these four. Which one is it? The third one. Thanks, Morelli. This one. Because I'm going to be going up, flattening out, and going up. Now, x equals c is still a critical point, but it is a situation where we don't have a max or a min. But through an analysis of the signs of the derivative, we can now say, like, yeah, c, cool, critical point, still a critical point, but neither a max nor a min. Okay? So now we got to work on how do we create this, okay? So first question before we get into doing this step 2 is what separates positive from negative values? Let me show you a situation. Here's a function. What separates its positive values from its negative values? Well, here are some positive values. Here are the negative values. A lot of us say the x-axis. But what is the value on my x-axis? Like the y value? 0. Like a 0 separates positive from negative things. So zeros are important because zeros must be in between positives and negatives. Now, there are other situations when you can change signs. Like if you have a asymptote, that means you have an undefined. You have positive values up here. You have negative values up here. Same things occur with jumps and stuff like that. So zeros and undefined. Okay, well, we've been finding when f prime is 0 and when f prime is undefined. All right, cool. Now, let's pretend that this question doesn't exist. Go ahead and flip over. Here's the actual question. The question is, f of x equals 1/3 x cubed minus 4x squared plus 7x. And now I'm not going to ask you to find the critical points. I'm going to say, find the locations. And when I mean locations, I only care about x coordinates where f has relative extrema. And we know relative extrema is just another fancy word for max min. You would do step 1, just like you've done. You would take the derivative of f and get f prime. Okay, I already did that for you. You would factor. To save time, I'm going to do this for you as well. X minus 7, x minus 1. You would set it equal to 0. You would solve. Okay, I'm doing step 1 for you. Now it's time to do step 2 for the first time. Okay? We have our critical points. We throw down our friend, the number line. Okay? Mr. Messer. Okay. Cool. Thanks. You need to head to the nurses at some point. You can wait till the end of class, or if you want to go now, you go now. Okay. All right. So you got your critical points. You throw down a number line. You throw down your critical points on the number line, making sure you leave a little bit of space to the left, and a little bit of space to the right, because we have x values that are bigger than 7. We have x values that are less than 0, less than 1. And we will say, hey, I know my slope, f prime, is 0 at 1 and 7. Okay, now let's focus on this interval right here between 1 and 7. We're going to worry about this interval too and this interval, but right now let's just focus between 1 and 7. I got to figure out my sines of f prime. Okay, that's the purpose. It's like, what do I do? And a lot of us might think it's like, well, I guess I got to start figuring out what f prime is at 2 and at 3 and at 4, and 5 and at 6, and maybe I have to worry about things in between those. Because like maybe f prime is positive at 2 and maybe it's negative at 6. Wait, actually no, that can't be true. I know for a fact that can't be true. I can't have positive value at 2 and a negative value at 6. Think about that. Why can't I change signs in between 1 and 7? Why do the signs have to be consistent? Okay, tell your neighbors. Now, I've already found all my undefined. You got it. Because the only way for me to change signs is if I had another 0 or undefined. But I know I found all of my zeros for f prime. I've exhausted all of them. There are only 2 zeros. So this is going to be very helpful. If I've exhausted all of my zeros and my undefined, signs of whatever you're looking at, let's just say f prime, signs of f prime will be consistent. In intervals. So I don't have to test 2, 3, 4, 5, 6. I don't have to test any decimals. I just got to pick one value. I don't know, 2, 3, 4, 5. Pick a value. It doesn't matter. I'm going to pick 3. Now, you can write down 3, but I want you to write it down really small and like barely make a tick mark, because a lot of people, if they write like too many tick marks, they like get confused with what they're doing. So it's like barely written down. Okay. Okay. How do I find the sign of f prime at 3? Tell your neighbor. Great. Plug it into f prime. Now here's what you all think to do. You're like, okay, let me plug it into f prime. And you're like, okay, f prime of 3 is 3 squared minus 8 times 3 plus 7. And you know what? I could do that. Right? Were you guys all thinking to do that? Oh, you weren't. Well, nice. Well, I'm thinking about doing this. But you know what? That's involved some arithmetic, and I'd like to do as minimal arithmetic as possible. Wouldn't you? So actually, I'm not going to plug it into that f prime because I have a simplified f prime. I have a factored f prime. And it's going to be much easier to plug it into this f prime, 3 minus 7 times 3 minus 1, than it will be to the original one, right? The factored f prime makes life easier. Because it's easy to find 3 minus 7 is negative 4, and it's easy to do 3 minus 1 is 2. But you know what? I don't care that this is negative 8. What do I care about? That it's negative. So I actually won't even do any numbers. I mean, the numbers up here, but all I get out of this is that 3 minus 7 is a negative, 3 minus 1 is a positive, and I know a negative number times a positive number is a negative number. Now, you could put a little tiny negative symbol over 3. But what else can I do? I can just put a really big negative symbol for all values between 1 and 7, because they all have to be negative. Focus! This is important. Okay. That's one of my 3 intervals. Now, you guys, tell me what the signs are to the right of 7. Tell me what the signs are to the left of 1. Go, do it. This is calculus gold I'm giving you guys. Don't fall asleep. Don't zone out. And then after you've done a sign analysis, I bet you could tell me if 1 and 7 are maxes or min. Question?
What if you have like a vertical sine at a graph, but it takes the whole way?
Then it wouldn't be a function.
Oh, yeah.
Depending on where you're going, yeah. There are different equations that aren't functions, like parametric equations, that we would do a different analysis. Okay, I plug in 8. Now do a really, really tall, small 8, okay? People who put too big of numbers, like, get confused. So, like, you don't even have to put it down here. Just be like, hey, I need to test my sine for one value to the right of 7, like 8. And maybe for the start, you're writing all this down. But eventually, you'll be able to just look, say, if I plug in 8, I have a positive times a positive. But for right now, do like the little work. Positive times a positive. I know it's a positive. Don't put just a tiny positive, because all of the values must be positive, whether it's 7.0001 or 1 million. I know f prime has to be positive because I found all of my zeros. If I try at, I don't know, negative 2, 0, whatever you want to, as long as it's to the left of 1. Negative 2 minus 7, negative 2 minus 1. Do you want to get the number? You can. You could do negative 9 times negative 3, but I don't care. I just want to know the sign. Negative times a negative is a positive. Okay, so what's going on at 1 and at 7? Tell your neighbor. Good. F must be going up, flattening out, down, flattening out, up, like that. We know cubics look like that, but now we know the locations of the humps. 1's got to be a max. 7's got to be a min. Okay, that's step 2. All right, I'd like you to change this and pretend you don't see anything. Please put a negative 3 in front of it. Give me a second, pretend like you don't see this. Like, clear this out. Okay, ready? Here's your real question. Given f, which is negative x cubed plus 3/2 x squared plus 18x, tell me, where are the maxes and mins? Why are you guys falling asleep in this class? Where are the max and mins of f? Well, I'm going to do step 1 for you. I'm going to take the derivative. Negative 3x squared plus 3x plus 18. I'm going to factor out a negative 3. Negative 3. X squared minus x minus 6. I'm going to factor that, and I get this.
Thank you.
You're welcome. I'm going to set that equal to 0, and I'm going to get this. You guys do step 2. All you need is 1 point. Don't need all of these. Just pick one that's in between those. That's all you'll need. Now, be careful. What's my simplified f prime? It's not just x minus 3 times x plus 2. It's negative 3 times x minus 3 times x plus 2. So let me show you what I would get if I tested my interval between negative 2 and 3, plugged in 0. F prime of 0 would be, watch, negative 3 times 0 minus 3 times 0 plus 2. That's negative 3 times another negative 3 times a positive 2. Oh my goodness, I have 3 things I have to worry about. Not just 2, because that negative 3 is still there. A negative times a negative is a positive, times a positive stays positive. That's the only thing I have to test. I don't have to look at negative 1. I don't have to look at 1 or 2. I know it's going to be positive. I found all the zeros. Okay? You guys do the other 2 intervals. Now that I gave you the heads up about that negative 3. Oh, you better hurry. And again, what are we doing? We're analyzing the signs of f prime. The signs of f prime will help us know the behavior of f. I know at negative 2 and 3, sometimes I forget to do this, we have signs that are 0. It's not positive or negative. Nope. That's good. Check your signs with your neighbor. All right. Now tell me, what's going on at negative 2? What's going on at 3? Do we have maxes or mins or neithers? No, that's good. That looks good. Check. Odom, stay awake. This is unbelievable. Can't believe you're sleeping. Okay. That arrow needs to go down from left to right.
Oh, okay.
Your picture's correct. But be careful with your arrows. All right, if I tested something at 4. Now look, I'm not even putting down 4. If I'm doing it very, very tiny because I don't want it to confuse you. You're just testing the sign at 4, which is testing all of the signs to the right of 3. I have negative 3 times 4 minus 3 times 4 plus 2. I don't care about the numbers. It's a negative times a positive times a positive. That's a negative. I'm testing at, I don't know, negative 4. Negative 4 is over here. Do I care? Like about the value? No. That's why it's so tiny and it doesn't matter because it's just a sign test. Negative 4 minus 3, negative 4 plus 2. Negative times a negative times another negative. Negative times a negative is a positive. Times a negative is a negative. Fantastic. Now we know that f goes down until -2. It goes up from -2 to 3. It goes down after 3. It flattens out at -2. It flattens out at 3. X equals -2 must be the location of a min. X equals 3 must be the location of a max. Hooray! Now, those are cubics. Those are easy. There's some function out there that's f that is some x to the 6th power. Super long function. Okay? But you know what? I've taken the derivative for you. The derivative, something. But I've done it already. And then I factored the derivative for you, so we're not wasting any time. It turns out the factored form of the derivative is that. I'm asking you, when does f have maxes and mins? Well, I have found critical points for you at 2 and 3 and 4. So now, let's do step 2. But 2 is a critical point. 3 is a critical point. And 4 is a critical point. Well, how do I test my sines, say, between 2 and 3? I don't have a whole number to plug in. What should I do? Great idea. Use a decimal. Decimals are okay. Now let me show you. I'm going to do one interval. This is important because this like screws people up. They're like, I guess I plug in 3. No. Plug in 2.5. Everything okay over there? Good. I'll take care of him. I got a tissue. Okay. He's dead. Ready. Watch. This is important. This is the reason why, like, trying to get numbers are just not necessary. Let's plug in 2.5 into our simplified factored f prime. Would you like to tell me what 2.5 minus 2 times 2.5 minus 3 squared times 2.5 minus 4 cubed is? That numerical value? No. But we don't care. Okay? We shouldn't care. Now, but be careful. Watch. Ready? We haven't seen any of these exponents before. Watch. 2.5 minus 2, that's a positive. Okay. 2.5 minus 3 is a negative. But square that negative, and you get a positive. 2.5 minus 4 is a negative. Cube the negative, it stays negative. Good. So at 2.5, my sign is negative, which means all of the signs between 2 and 3, whether you're 2.001 or 2.999, are going to be negative. Now, you guys do the other intervals, please. I'll show you a shortcut where if you just have one interval, you can find out the other interval pretty quickly. But not yet. I want you to go through this testing experience. Because it's always something you can fall back on. This is perfect. Okay? Getting the graph, you'll figure out. It's tricky, right? Negative, that means down. Okay, it looks like we correctly got negatives here, positives here, and positives here through testing of all of our points. Like, I'll just do one more example, and then I'll show you a trick to be able to fill out the sign. 3.5 minus 2, positive. 3.5 minus 3, positive, squared stays positive. 3.5 minus 4, negative, negative cubed, negative. So that's negative, okay? Now watch this. You guys remember multiplicities and when you were graphing very expansive polynomials? Like bounces, bends, right? You guys remember like y equals x? What happens with y equals x? Just goes through. It changes sign. But you remember how like y equals x squared? And if you have like a squared multiplicity, you bounce, right? You don't change sign, right? And if it's like a cube, you're going to go through. You might bend through, but whatever. You still change signs with x cubed. Watch. At x equals 3, the multiplicity of the root x equals 3 is 2. I look at the exponent, that's the multiplicity. Which means like at x equals 3, my graph reacts like x squared. Which means at x equals 3, we don't change signs, we bounce. Now let's go to the left of 2. I already tested this first interval. At 2, the multiplicity is 1. Y equals x just passes through the x-axis. It changes sign. Well, change signs at 2. X minus 4 cubed. The multiplicity is 3. It's an odd multiplicity. We change signs if your multiplicity is odd. So you got a negative here. Put a positive there. Okay? Might save you some time, but if you don't know what I'm doing here, don't do it. Because what's important is getting the correct sign, understanding what F is doing. Ready? This is what F's doing. Going up, flattening out. Coming down, flattening out. Going down, flattening out, coming up. We have our first instance where at x equals 3, it's still a critical point. The derivative is still 0. It's still a critical point, but it's neither a max nor a min. It's a point where the slope is 0, but it's not a max or a min because we don't go up, down, or down, up. Keep your phone away. X equals 4, we know it's a min. Okay? Now watch this. Let's go back to a previous one. If I just knew the signs to the right of 3 were negative, the multiplicities are 1 and 1 for both positive 3 and negative 2. Once you find the negative signs, change signs, change signs. Okay, test one interval, use multiplicities, might save you some time. Okay, all right. We would easily be able to take the derivative factor, get 1 and 5. This is very similar to the ones we've already done, so I'm not going to spend much time. If I plugged in 6 into my simplified f prime, don't even copy this down, just watch. 6 minus 5, 6 minus 1, positive. Multiplicity is 1, multiplicity is 1, change signs, right? Increasing, decreasing, increasing for f, max, min. Okay, we've done enough of these x cubed. But now, I'm tired of doing work for you. I'm tired of doing step 1 every time. And I want you to see the power of this analysis and this step 1 and this step 2 combined. I'd like you to be a human graphic calculator. Let's see if you can do it. Yep. You'd say it's neither. It's a critical point, but not a max nor a min.
So how do you get constant?
I mean, they're all constant. When the derivative is 0, you flatten out. So it's flattened out. Yeah, that's the neither situation.
This is nice.
Yeah, it's a neither max or min. It's a critical point, not a max or min. Okay? This is a critical point, not a max or min.
But what would you call it? Sine or neither?
It's a critical point, but it's not a max or a min. That's it. Yeah. Good start. Good step one. Good step one. Good step one. Bad step one. Good step one. Good step one and two. Wait. No, bad step one. Can't get step one, you're not going to get step two right. Good step one. Careful. Not just one X can be pulled out. Two X's can be pulled out. Good step one. You got to get step one right if you're going to be a human graphic calculator. Good step one. Now let's go to step two. Bad step one.
No.
If you don't get step one right, you're not going to get step two right. X squared.
No.
Now, I would like you to sketch what this graph looks like. Good step one and two. Good step one. Bad step two. Yeah.
I'm confused on what you're saying. Is this a bounce?
It doesn't change sign.
So like you're bouncing on negative.
Wait. No. You're thinking about slope. Think about just y values. Positive y values, bounce off the x-axis, positive y values. Y values, not slope. Bad step one. I pull out two x's. It's just x minus 1. All right, for you bad step oneers, you got to get step one right. Most of you are good with your derivative, 4x cubed minus 4x squared. But your factoring step was a little off. It should be 4x squared times x minus 1. There's only two critical points. There's only two zeros, 0 and 1. Okay, fix your step 2 if your step 1 was wrong. Your step 2 is going to be wrong. You could use multiplicities here. We'll find out. You know what? I have a calculator, so we'll check your answers. Yeah, well, it's nice to see that you guys are more powerful than you think. Okay.
If I got it right.
You just need to test one interval. Let's test at 2. 4 times 2 squared, 2 minus 1, positive. If you tested your signs on every interval, you'd be correct, okay? If you don't understand this multiplicity thing, don't use it. The multiplicity of my root x equals 1 is 1, which means I will change signs at 1. The multiplicity of x equals 0 is 2, which means I will not change signs at 0. If you did not understand that, then just plug in 0.5. 4 times 0.5 squared, 0.5 minus 1, positive times a negative. Plug in negative 1. 4 times negative 1 squared times negative 1 minus 1. Positive, because it's negative 1 squared, times a negative. That's a negative. Okay. You guys think the graph decreases until x equals 0. It flattens out. And it decreases from 0 to 1. And then it's going to go up. It's going to have a min at 1. You probably graph something like this, right? Did you? Yeah? Look at you. You're a human gravity calculator. Awesome. Boom, boom. Now, your sketches, they're fine. If we were to be more specific, we would plug in 0. We would plug in 1 to find the point, right? And then all of a sudden, our graph is even more accurate. Yeah, maybe. Right now, we're just focused on the x-coordinates, okay? All right, cool. But now I'm going to blow your mind with different types of questions, like this one. All right, let's quickly get to this one. So here we go. Skip this part. Relative extrema of f. Okay, there's a graph. Relative extrema. Ready, set, go. Corkle. Way to go. Of course, like it's easy. It's easy. We have a max at -1, a min at 2. Yeah, no. If you think the answers are -1 and 2 are our max and our min, you think this class is easier than it really is. Okay? And that's okay because we all do it. The problem with you students is you don't read carefully. You don't understand what you're given. This is not the graph of f. This is the graph of f prime. Well, what have we been doing with f prime? We have been using our number line. We've been finding the zeros of f prime. But you might be saying, well, Mr. Messner, isn't this a zero slope? Isn't this a zero slope? Why isn't -1 and 2 still considered to be our numbers that go down here? Well, that would be when f prime's slope is 0. That would be when f double prime is 0. I don't care about f double prime up here. This would be when f double prime is 0. I don't care about that. So where are the zeros of f prime? Here, here, and here. Those are the zeros of f prime at -3, 1, and 3. These are the critical points of f. These are the possible max and mins of f. Tell me. What are they? Maxes or mins? Okay, I got 0 here. I got a 0 here. I got a 0 here. You might be thinking, well, don't I have positive slopes? So it's positive here? Nope. Nope. No. That would be f double prime values are positive. What I have are negative y values of f prime. F prime's y values are negative when it's below the x-axis. A 0 separates positive from negative values, right? Here I am with positive f prime values because they're above the x-axis. The y values of f prime are positive. And then I have negative f prime values from 1 to 3. And then I have positive f prime values after that. All right, tell me. X equals -3, max or min? Min. X equals 1, max or min? X equals 3, max or min? All right. how we do that.
Oh, yeah.
You'll need to practice tremendously next Tuesday before I see you on Wednesday.